Chances are you're watching this on some kind of computer right now. We use them all the time. They're everywhere. But have you ever really stopped and thought about what's going on under the hood? Well, that's what we're about to do. We're going to peel back the layers and take a journey deep inside the machine.
So yeah, what is going on in there when you move your mouse or tap a key? I know it can feel like magic, but it's not. Not at all. It's actually a super organized, incredibly fast process. The best way to think about it is like a high-tech workshop running at lightning speed. And for the next few minutes, we're going to get a peek inside. So here's our game plan. First, we'll figure out the whole point of this workshop. Then, we'll check out the physical tools, the hardware. After that, we'll meet the foreman, the software, that tells everything else what to do. We'll even learn the secret language of the workshop's blueprints. And finally, we'll see how all these workshops connect to each other across the entire globe.
All right, first things first. Before we start looking at all the cool gadgets and machinery, we really need to understand the big picture. What is the fundamental purpose of this whole workshop? What even is a computer when you get right down to it?
You know, at its core, a computer is actually pretty simple. It's just a machine that takes in raw data, that's your clicks, your typing, all that stuff, and it processes it, chews on it, to give you back something useful. A finished document, a website loading on your screen, you name it. It just turns raw materials into a finished product.
And get this, every single computer, whether it's a giant supercomputer or the phone in your hand, follows this exact same four-step dance. It takes an input from you, it processes that information, it gives you an output that you can see or hear, and then it stores the result if you need it later. Input, process, output, storage. That's the heartbeat of every computer out there.
Okay, so we've got the basic flow down. Now for the fun part. It's time to pop the hood and actually look at the physical stuff inside, the hardware. This is the workbench, the power tools, and the engine room, where all the real work gets done.
We all know what these things look like from the outside, right? Sleek boxes, laptops, they're designed to look clean and simple, totally user-friendly.
But then you crack one open, and wow, that's where the action is. It might look like a crazy, complicated city of circuits, but trust me, every single piece in there has a very specific and very important job to do in our workshop.
So let's do a little meet and greet with the main crew. First up, you have the CPU, the Central Processing Unit. This is the master craftsman, the brain of the whole operation. Then you've got RAM. Think of RAM as your workbench. It's the temporary space where you keep all the projects you're working on right now. More RAM means a bigger workbench, so you can juggle more things at once. After that is storage, your hard drive or SSD. That's the giant warehouse where you keep everything long-term. And of course, you've got your tools to get work in and out. Your keyboard, mouse, and monitor.
And to give you an idea of just how big our workshop's warehouse has gotten, check this out. Back in the 80s, a floppy disk could hold about 1.5 megabytes. A CD in the 90s held 700. A modern solid-state drive, an SSD, can hold over 1 million megabytes. We're talking a terabyte or more. That's not just going from a filing cabinet to a bigger one. It's like going from a shoebox to a warehouse that covers a city. It's absolutely wild.
Okay, so we've got all this incredible hardware, right? The tools, the benches, the whole setup. But so what? How does any of it know what to actually do? Well, that's where our workshop's foreman comes in. And that foreman is the software.
Simply put, software is the intelligence that brings the machine to life. It's all the programs and instructions that tell the hardware, the CPU, the RAM, all of it, exactly what to do, step by step. You know, without software, your brand new, top-of-the-line computer is just a really expensive doorstop.
Now, software basically comes in two main flavors. First, you've got your system software. Think of Windows or Mac OS. This is the workshop manager. Its job is to keep the lights on, manage all the resources, and make sure everything is running smoothly. Then you have application software. These are the specialists you bring in for a specific task, like your web browser, a video game, or a photo editor.
And I'm sure you recognize these guys. On one side, you've got the managers, Windows, Mac OS, Android, running the whole show. And they coordinate all the specialists you call on. Chrome, Photoshop, Word, you name it. For a workshop to be productive, you absolutely need both.
So the software foreman is giving instructions to the hardware tools. But what language are those instructions written in? Let's go one level deeper. It's time to look at the secret code of the computer's blueprints. At the very, very bottom of it all, this is what a computer actually sees. Just a long, long stream of zeros and ones. It might look like total nonsense, but that string of numbers right there, that's just the computer's way of spelling out the word hello. And believe it or not, the idea behind it is incredibly simple.
This language is called binary,
And all it is, really, is a massive set of light switches. A 1 just means a switch is on. A 0 means the switch is off. That's it. And by grouping millions and billions of these tiny on-off switches into specific patterns, a computer can represent everything. Every letter you type, every color on your screen, every sound you hear.
So you might be thinking, okay, if it's all just ones and zeros, how does my computer know the difference between a photo and a text message? Well, that's where file extensions come in. When you see .jpg or .docx at the end of a file name, it's basically a little tag that tells the workshop manager, hey, this is a picture file. Go get the photo specialist program to open it.
All right, so we've built the fully functional workshop. It's got its tools, it has its foreman, and it understands its blueprints. But a single workshop all by itself can only do so much. The true power of modern computers really explodes when we start connecting these individual workshops together.
These connections happen on a few different scales. In your home or office, you've probably got a local area network, a LAN, that connects your devices. Zoom out a bit, and you have a wide area network, a WAN, which might connect computers all across the city. And the biggest, most mind-boggling WAN of them all? Well, that's the internet, the global network that connects billions of these workshops all around the world.
The main thing to remember is that the internet isn't some magical cloud floating up in the sky. It's a real thing. It's physical cables running under the ocean. It's servers and giant data centers. It's all these computers physically linked together. Your machine right now is just one workshop in a vast planet-spanning system.
So there we have it. We went from a simple box to a high-tech workshop to the foreman giving orders down to its secret language of ones and zeros and all the way back out to a global network. We've seen that a computer isn't magic. It's a tool, an incredibly powerful one. Which leaves us with just one final question for you. Now that you know how this amazing workshop operates, what will you build with it?